Okay, today we're gonna speak about workout volume and workout frequency. Very important parameters if we want to create a workout plan for us or for our clients. If we're gonna speak about these two topics together because they are very related. Frequency can depend of workout volume, and volume can depend of frequency. So, but if we want to speak about this, we need first to speak about some other parameters can have strong influence on workout volume and frequency. We're gonna speak today about fatigue, and we need to understand mechanisms of fatigue and how fatigue can influence workout volume and workout frequency, and how workout frequency and workout volume can influence fatigue. This is a strong correlation between these three parameters. And also we're gonna speak about anabolic signaling, and we're gonna speak about muscle protein synthesis, actually better say myofibril protein synthesis. Okay, let's speak first about fatigue, and let's define fatigue. We can define fatigue like a temporary losing of strength. So let's say fatigue is not usually our personal feeling, how we feel, are we fatigued or not. Fatigue we can measure, and we usually measure fatigue through a maximal strength of lifting exercise. Of lifting weights. I'm gonna give you example. For example, if you used to lift 100 kilos 10 times, and you want to repeat that or in the next set or in next workout, and you are not able to repeat this weight with this number of reps, probably you are fatigued. Also, if we are not able to progressively overload, probably we have accumulated fatigue. So we have two types of fatigue. We have a central nervous system fatigue, and we have a peripheral fatigue. What that means: central nervous system fatigue happening in the central nervous system, and peripheral fatigue happening directly in a muscle. So we need to understand, to have a full muscle activation and full voluntary activation of muscles, how we say, we need two things. We have maximal activation of motor units for what is responsible central nervous system, and we need highest possible tension in each muscle fiber which is activated, and on this part can influence our peripheral fatigue. Let's start first from a central nervous system fatigue. CNS fatigue is fatigue which we can divide on two parts. We have a spinal and supraspinal fatigue. So spinal, that means happening in a spinal cord, and supraspinal happening in our brain, actually in the motor cortex. Before we start to speak about the mechanisms of this type of fatigue, let me tell you something what is very important to understand both types of fatigue: central nervous system fatigue and the peripheral fatigue. We need to know that to our muscles command our brain, actually our motor cortex sending something what we call central motor command. That is electrical impulse for our motor cortex, and this electrical impulse traveling through our body to our muscles. So we need to know that way, because that's going to help us later to understand both types of fatigue. So that electrical signal traveling through our spinal cord, actually traveling through a motoric nerve, and that signal coming to our cell. Then that signal travels around the cell membrane, on which we have voltage sensor, which can detect that electrical impulse, receive that electrical impulse, and then that electrical signal is converted in chemical signal. That gonna happen everything in one part of the cell we call sarcoplasmic reticulum, in this sarcoplasmic reticulum, that actually electrical signal gonna release calcium ions, which gonna trigger one molecule which we call troponin, and troponin gonna help to with supplying of ATP, adenosine 3-phosphate, energy we're using for all of this, to actin and myosin, two proteins which we have in a contractile unit of muscle cell, which we call sarcomere, to slide over each other, what we call muscle filament sliding theory. And on that way, our sarcomere actually, on the end, our muscle gonna generate force to move something. Sounds very complicated, but this is a very important to know if we want to understand both of mechanisms of fatigue, central nervous system fatigue and peripheral fatigue. Okay, so what is central nervous system fatigue? That's inability of our motor cortex to send a full signal to our muscle and to activate as more as possible motor units. We know that hypertrophy depends the most of activation of a number of motor units. Actually, of course, we mentioned already we need also tension in each muscle fibers, but we cannot achieve a tension in muscle fiber which is not activated. So the first step and the most important step is to activate as more as possible muscle fibers if we want to achieve a maximal tension in each muscle fiber. So again, muscle fiber which is not activated cannot make a tension. So our goal when we speak about hypertrophy, first goal is to activate as more as possible muscle fibers in one muscle if we want to achieve a maximal hypertrophy. This is a more important for advanced lifters and lifters reach plateau than for beginners, because we know that beginners are more sensitive on muscle activation, and it's much easier to trigger hypertrophy in beginners than advanced lifters. So how we can have this central nervous system fatigue? Usually through one mechanism we call afferent feedback. What is afferent feedback? That's negative sensation we receive from our muscle. That's actually a perception of effort we receive. In our muscle, when our muscle making contractions, we accumulating metabolites. These metabolites giving that negative sensation to our nervous system, and our nervous system gonna reduce a signal to our muscle. When we reduce a signal to our muscle, number of motor units, actually number of muscle fibers will be reduced. And this is probably some kind of protective mechanism of our body to avoid overuse, to avoid injuries, and to avoid excessive spending of energy. And this is a main mechanism of our body, of our central nervous system fatigue. So what can cause any kind of workout, of course, can cause, but what can cause excessively this afferent feedback? So number one, that's long workouts with so many sets. As more as we have sets, we're gonna produce more metabolites. Also, as more as we have repetitions in one set, each repetition creating more metabolites, and we're gonna have more negative sensation for our central nervous system. So we need to reduce the number of sets, and we need to reduce the number of repetition in a set. So that's a main thing what we want if we want to, what we need to do if we want to reduce central nervous system fatigue. Okay, let's go further. Let's go on peripheral fatigue. During the muscle contractions, we have release of calcium ions. And we said that calcium ions going from sarcoplasmic reticulum to cytoplasm. In cytoplasm, they stay there before sarcoplasmic reticulum suck them back. But when we have too strong contraction, when we have too often contraction, we don't have a time. Actually, sarcoplasmic reticulum doesn't have a time to suck back all calcium ions from cytoplasm to sarcoplasmic reticulum back. So always after each contraction, some part of calcium ions gonna stay in cytoplasm. So again, as more as we have contractions, as more as we have sets in a workout, it's more possible to have a more calcium ions in cytoplasm. What can happen? This amount of calcium ions in cytoplasm can reduce sensitivity of calcium ions, so this can cause peripheral fatigue. In some cases, peripheral fatigue can be good, but in some cases, peripheral fatigue can be bad. Generally, it's a bad, but in the moment, if we reduce ability in one muscle fiber, that means another muscle fiber will be activated from our central nervous system. As we said in the beginning, as more as muscle fibers we have activated during the set, we have more chances to achieve higher hypertrophy. So one of other things what can happen, this calcium ion can destroy structures in our sarcomere, in our contractile unit of our muscle. So can destroy cytoskeleton and can destroy that layer around our cell, that membrane we have around our cell. And that also can disable our cell to receive impulse sent from central nervous system, so we will not have in that case the highest possible activation of our sarcomere, and we will not have a proper muscle contraction. We will not have enough activation of motor units, what's gonna reduce the tension in our muscles. So now, when we know these two mechanisms, we need to know that how much recoverment we need after fatigue. They did a lot of studies of this, and some things I can tell you. If we said that we can measure our fatigue through reduction in strength. So let's say like this: if reduction of strength is reduced 20%, we need 2 days to recover. If our strength is reduced 50%, we're gonna need up to 7 days to fully recover from that workout. What that means? If you, in the beginning of your workout, doing bench press, was able to lift 100 kilos 10 times, and then on the end of your workout, you are able to lift 100 kilos only 5 times, that will reduction in strength 50%. From this to fully recovered, we need up to 7 days. What that mean? That mean for some beginners, even with not fully activation of our muscle, you will be able to produce new muscle growth, to produce hypertrophy. But for some advanced lifters, because we know that for advanced lifters we have the highest possible muscle activation, we need the highest possible motor unit recruitment, we will not be able to trigger muscle growth. So it's essential for natural lifters, advanced lifters, to be fully recovered. What we can do, let's say like this: recoverment after one set to failure per exercise per workout can take from 24 to 48 hours. 3 sets to failure, recoverment can take up to 72 hours. And more than 5 sets, actually 5 sets can take more than 72 hours to full recoverment. Okay, we need to know like this, what we can do to prevent excessive need for recoverment. Okay, first we can use isolation exercises instead of compound exercises. We know that isolation exercises produce less fatigue than compound exercises. So we can use a single limb exercises, because we know that single limb exercises produce less fatigue than the exercises we're gonna do with both arms or both legs. So we can avoid the stretch position, because all stretch position and loading stretch position gonna open calcium ions channels, and calcium ion gonna finish easier its cytoplasm. And we said that calcium ion can decrease sensitivity on electrical impulses and also can damage structure in our muscle cell, what can cause a lower impulse, actually inability of our cell to receive impulse, proper impulse in a full capacity from our central nervous system, actually motor command. So we can reduce a number of sets in a workout, because more sets produce a more fatigue. And we can reduce a number of repetitions in our workout. As we said in the beginning, more repetitions, more calcium ion stay after each contraction, and more fatigue will be produced. What else has a strong impact on fatigue? Sets going to failure has a more impact of fatigue, because more muscle fibers, fast twitch muscle fibers, will be activated, and more calcium ions will be produced when we're doing sets to failure. When they're doing studies, when they compare sets going to failure and 1 rep before failure, they found much more fatigue in sets going to failure, but hypertrophy results are very similar. So it's much better to stop 1 repetition before failure, because this is gonna help us to prevent accumulating of excessive fatigue. And also, one more thing we can do to prevent fatigue is to reduce muscle damage, actually. But all of these things I said gonna reduce muscle damage. Muscle damage has a strong influence on fatigue, and that actually can increase in a second wave of inflammation, can increase the central nervous system fatigue and reduce our ability to produce a force. So all these things I mentioned, these 5 things, gonna prevent you to make excessive muscle damage, which gonna increase a central nervous system fatigue. So this was everything about, let's say, as short as possible, I said about fatigue. So next we're gonna speak about anabolic signaling. Okay, let's speak about anabolic signaling. When we're lifting weights, we're creating mechanical tension. In our muscles, we have mechanical receptors which can detect that mechanical tension. And in a process we call process of mechanical transduction, this mechanical signal will be transformed in a chemical signal, and that will be through anabolic signal. And anabolic signal gonna trigger a hormonal release, and hormonal release gonna trigger a muscle protein synthesis. So first we need to know that anabolic signaling is a local process. If we exercising our biceps, we're gonna release anabolic signal in our biceps, what gonna trigger hormonal response, which is a systematic hormonal release. And systematic hormone release again gonna stimulate local muscle protein synthesis. So we need to know that anabolic signaling and muscle protein synthesis are processes, local processes. One of the most important for us anabolic signal is mTOR. mTOR, we call it's a regulator of muscle growth. And this is the most important, most studies measure this anabolic signal. mTOR works over something what we call P70S6. And this is something we can find in ribosomes, and we call that ribosome biogenesis. What that means? We need to know that ribosomes are machine for production of muscle tissue. So our ribosomes convert amino acids in a muscle protein, and actually that's a factory for building muscles. So what is also important when we speak about anabolic signaling? We need to know that we are limited with the amount of anabolic signaling, and always I'm telling, more doesn't mean better. So sometimes is less better, because we have that also fatigue. About fatigue we spoke in the first part, but we need also to know that we have a limit. We have the limit of anabolic signaling we can produce. Each set we do over that let's say maximal over that threshold, let's say like that, will be wasted set and will be something what we call a junk volume. So that set will not produce any gains, but gonna produce fatigue. And we know that fatigue can influence on a bad way, not just workout we're doing now, can influence workout we're gonna do tomorrow or day after tomorrow. And also we know that doesn't matter we're doing today lower body, fatigue we accumulate from lower body can influence fatigue, our workout we're gonna do for upper body tomorrow. Why? Because we have one central nervous system, and our central nervous system command both to our lower body and to upper body. So we need to figure out how many sets we need in a workout to trigger maximal hormonal release, actually maximal anabolic signaling, what's gonna trigger maximal protein synthesis and maximal hypertrophy, actually maximal muscle growth. So that will be our goal right now. I read a lot of studies, let's say related with this, and as I'm telling always, we need to be very critical with the studies. We cannot just read study and we said that's it. And we need to look a lot of parameters in each study. What I realized first when I read some of the studies, I realized that those studies are acute studies. What that means? They just invited some people one day, they did some workout protocol one day on them, directly after that they measure anabolic signaling, write down the data and present that data like data, how many anabolic signaling producing 1 set, 3 sets, 5 sets. So what this shows to us, not so much. Why? Because that's an acute study. We need a longer term studies to be able to take in account fatigue. We spoke again about fatigue before we start to speak about anabolic signaling. So fatigue can influence our performance in the workout, also can influence anabolic signaling. So we need a study which is like long-term study which gonna take in account anabolic signaling. And I found Radelli study which is made 2015, and what is good with that study, beside that it's a 12-week study, they have trained participants there. It's very important to have a trained people in a study, because trained people reacting mostly different than untrained people. So they did full body workout. They did 3 workouts in a week, and they did 3 exercises. That was the deadlift, bench press, and squat. So that was the structure of the study, actually design of that study. And they divided the people in 3 groups. One group did 1 set to failure per exercise per workout. Second group did 3 sets per exercise to failure per workout, and third group did 5 sets per exercise per workout. And they measure anabolic signaling after last workout, and what they discover. They measure mTOR. They discover that first group increase mTOR 100%. Second group increase mTOR for 150 to 200%. And third group, this 5 sets group, increase anabolic signaling from 200 to 300%. So what we can see from this, that with the more sets we increasing anabolic signaling, but we can see also that increasing of anabolic signaling, it's not linear. What that means, if we double number of sets, we will not double increasing in anabolic signaling. So, and probably as more as we go with the sets up, that anabolic signaling will be lower and lower. So the highest anabolic signaling I found in any study was exactly this one with 5 sets, 300% increase anabolic signaling. So also when we speak about critics about the study, first we need to see that highest group, which we can say did 5 sets to failure for each exercise, and they did 3 exercises. That's in a total 15 sets to failure in each workout. 3 workouts per week. We're gonna have 35 sets to failure in a week. That's very low volume. They did compound exercises, and we said in the first part that compound exercises producing more fatigue than isolation exercises, but they did only 35 sets to failure in a week. What that means, if you compare, for example, with my workout, and I'm someone who doing very low volume workouts, I'm doing only 2 sets per muscle group in a workout, 2 sets to failure or close to failure. And if we count all muscle groups, because I'm doing all isolation exercises, I'm doing 57 sets in a week. I'm doing very low volume, but just see how low volume doing this group, like high volume group in this study, much lower than I'm doing. Another thing we need to know, that we said that hormonal release, actually not hormonal release, anabolic signaling is a local process, and they measure in vastus lateralis. How they measure anabolic signaling? They measure with a biopsy in vastus lateralis. Vastus lateralis is a muscle they usually measure taking actually biopsy, because it's most suitable for this process. And in this study they did a biopsy of vastus lateralis. Also, we need to know that vastus lateralis is a muscle with the lowest voluntary activation. If we compare vastus, or actually that's a quadriceps muscle, part of quadriceps muscle. If we compare this muscle, for example, with the biceps, which has high voluntary activation in the biceps is 98%, and in our vastus lateralis is only 85%. What that means? We know that muscles with lower voluntary activation, it's much more resistance on damage, on muscle damage, which cause fatigue. We don't have that data because they didn't take in any study from any other muscle this, but we can just predict that that fatigue, if it's taken from pectoralis major, can be for sure not higher, can be same or probably lower. So even anabolic signaling will be probably lower, and the differences between 1, 2, 3 sets will be even smaller. This is a very important part of this study. We have one more interesting study. We don't have. I don't want to speak more about anabolic signaling, but I can tell you like this. They did a lot of studies to discover how much hypertrophy gonna bring first set, second set, third set, etc. So when you collect all data based on if you're doing per muscle group in a workout 3 to 5 sets, first set contribute to hypertrophy from 60 to 70%. 60 to 70% you're gonna get the benefits from first set. From second set up to 20%. So in the first 2 sets you're gonna get the benefits from the first two sets 90% to hypertrophy. Also, they count and they did this meta-analysis where they took 15 relevant studies on trained lifters, and they counted each set after 5th set in a workout per muscle group contribute to hypertrophy only 0.37%. So only 0.37%. The question is that worth it to go over 5 sets and risk to be overtrained, to accumulate fatigue just because of 0.37% more gains? Of course, that's not. But I'm gonna tell you something else beside that. As we said, first 2 sets brings 90% of all muscle gains you're gonna have in a workout from all sets you're gonna do for that muscle group. In most of these studies, both rest between these 2 sets were too short. They did from 60 to 90 seconds rest between 2 sets. So second set probably can contribute much more than in those studies they did. Why? Because we know that when we're doing a muscle contractions, we're accumulating metabolites in our muscles, and metabolites blocks our muscles to work, to be fully activated, to contract with a maximal potential. We need at least 2 minutes to rid these metabolites from the muscles, especially trained lifters with a higher percentage of fast-twitch muscle fibers, which contain less mitochondria, which help us to actually rid this waste product from our muscles. So they did from 60 seconds to 90 seconds, that's a less than 2 minutes. But probably to clean up all metabolites, we need much more than 2 minutes. And we need to know, okay, cleaning metabolites is not linear. Most of metabolites we're gonna clean in the first 2 minutes, but we need more to clean metabolites. So longer rest periods between first and second sets will be more beneficial to increase efficiency of our second set. But what I'm doing with my clients and what I'm doing in my workout is one thing which gonna increase efficiency of a second set much more. What is that? That's some kind of potential of potentation actually of our nervous system. This we call post-activation performance enhancement. What that means? After one heavy set, potentation in our nervous system going up and going will be increased up to 14 minutes after that heavy set, but gonna reach a peak after 5-6 minutes. What that means, if you wait 5 to 6 minutes after your first working set to second working set, you're gonna reach a maximum of that potentiation. What that means, probably you're gonna, if you lift 100 kilos 10 times in the first set, probably you will be able to lift this 100 kilos 1 or 2 reps more. So you're gonna do 11 or 12 times in a second set. Cleaning metabolites and reaching maximal of this neurological potentiation, nervous system potentiation after 5-6 minutes, gonna increase efficiency of a second set. And I'm guarantee you that in the 2 sets on this way, you're gonna have more than 95% of all muscle gains, and beside that, fatigue will be reduced on minimum. So this will not accumulate almost no fatigue. You will be able to recover much faster, to reach your full potential in each workout, and to increase the frequency of workout. What we're gonna see later, each workout is stimulus for muscle growth, and frequency is very important to have, because this is like a stimulus. We want stimulus for our muscle growth as more as possible. We measure a muscle protein synthesis. We can measure actually muscle protein synthesis. What is a muscle protein synthesis? That's a whole synthesis of our proteins happening in our muscles, but also happening in a whole muscle. They count together synthesis for contractile proteins and non-contractile proteins. What that means? Contractile proteins are usually actin and myosin. We all usually mention, and that's real muscle growth, but also protein synthesis in sarcoplasm we use for enzymes, for metabolic process, for energy, etc., etc. So this is a muscle protein synthesis. And also we have a myofibril protein synthesis. That's a protein synthesis happening only for a muscle growth. One fun fact, only 11% of all muscles, of all proteins we eat, we gonna use for building a muscle tissue. Only 11%. So we don't have today enough good technology to know which amount of protein we're gonna use for muscle building and we're gonna use for muscle repair. This is a very important to know. Before 10-15 years ago, when they measure muscle protein synthesis after some workouts that produce a lot of muscle damage, they realize that muscle protein synthesis is increased and prolonged. And what was the conclusion of scientists in that time? That muscle damage is mechanism of hypertrophy and increasing a muscle protein synthesis. Because increasing a muscle protein synthesis, that's true. But we need to know, today science know that muscle damage is not a mechanism of hypertrophy. Actually, building new muscle tissue and repairment of muscle damage, it's completely separated process. We cannot know how much proteins we use for building new muscle tissue, how much proteins we use for repairment of muscle tissue, but we can predict. Usually when we're doing workouts without a muscle damage, muscle protein synthesis is very short, up to 24 hours. But when we have muscle damage, this muscle protein synthesis is prolonged. So probably in a first 24 hours, we have in the same time muscle building and muscle repairment, and then in up to, let's say, 48 hours, in most of cases, we have muscle repairment. So what this is telling us? Of course, there are differences between beginners and advanced lifters. Beginners, they have prolonged muscle protein synthesis. That's probably because of more muscle damage. And advanced lifters, they have a shorter muscle protein synthesis. So what this telling to us? This telling to us that advanced lifters need a more frequent workouts. Why? Because when we speak about the natural lifters, only way how you can increase the muscle protein synthesis is through mechanical loading of muscle, actually through a weightlifting. People who take steroids can increase, taking a chemical compounds can increase the muscle protein synthesis, actually skipping mechanical tension, skipping workouts. But of course we know that they have synergistic effect. Workout and taking steroids have a synergistic effect, and the result is better. This is not of course advised to take any kind of this stuff, just telling effect. Okay, if you are a natural lifter, it's very important to be in positive protein balance. So we need to know that we have protein building in a body and protein degradation in a body. And if we are in anabolic state, if we're building a protein, we're building a protein. If we have a muscle breakdown, we are in negative protein balance. So we cannot be in between. We are building muscle, or we're losing the muscles. So if this protein synthesis in a muscle is increased only 24 hours, what they're telling us, that frequency of workout not just gonna increase muscle protein synthesis, gonna decrease the time when we have a muscle breakdown, so we will be able to be in that positive protein balance, and that's gonna help us to lift, to build more muscle tissue during the time. Is that true? We're gonna see in the next part, where we're gonna speak about the frequency of workout and about volume of workout directly. So let's say first, what is a volume? Traditionally, they used to look on a volume like on something that is only a number of sets in 1 week, but never thought about the quality of the sets. So what that mean, a quality? If we have one beginner, if we have from another side one advanced lifter, and we can say volume for chest for both of them is 10 sets per week. Are those sets which gonna bring same gains? Of course not. We know that beginners, they have increased perception of effort, and they're gonna stop much before a muscle failure. And from another side, we know that sets closer to muscle failure brings more gains. Is a volume of 10 sets per week of beginners same like 10 sets volume for advanced lifter? Of course is not. Much more gains gonna bring volume of advanced lifter, because they are closer to failure. So then they went further. They said load volume, where they count all weights they lift during 1 week, and each week they try to increase and do through that progressive overload. But is this a perfect method to estimate volume, actually to compare volume? Of course not, because we don't know in how many sets we did that load volume, and how many repetitions. We said that less sets and less repetitions are more beneficial for muscle growth, because produce a less fatigue, which is very important. It's very important to reduce fatigue for better muscle activation. So we have maybe the most perfect method how we can estimate a load. That's something what we call stimulative reps. What are stimulative reps? Stimulative reps, we count only 5 last reps to failure. And this is the best way how to count volume. Actually, only sets which gonna stimulate the muscle growth gonna be taking in account, not other sets, and wasted repetitions. This is a very important for advanced lifters. Okay, from previous knowledge we understood that 2 sets gonna contribute the most of muscle to muscle growth, especially on a way I propose and I'm doing with myself and with my clients. And then based on these 2 sets, we can have a very low volume. Low volume gonna help us to decrease fatigue as more as possible, especially if we use some techniques like avoiding stretch position, which we know that increase fatigue. Most of muscle grows perfectly in a middle position, in a short position, and this position gonna reduce fatigue a lot. Then we're gonna reduce a number of sets, we're gonna reduce a number of repetitions. 5 to 8 repetitions for advanced lifter and semi-advanced lifters will be the most beneficial, because they are gonna reduce muscle damage and need for rest. Actually gonna reduce fatigue. Avoiding going to failure, because we know that last rep will not bring that much benefits, like gonna make a damage on our muscles and increase fatigue. So this low volume gonna give us a chance to have a more often workouts. As I said, you need to look on workout like a stimulus, and we need a stimulus as often to increase the muscle protein synthesis and spend more time in that anabolic state than in catabolic state. So we need high frequency, and we will have a low volume. When we avoiding a muscle damage, when we reduce the fatigue, we will have that chance to have at least 2 times per week. But my suggestion will be 3 times per week, 3 times per week frequency for each muscle group. For example, in my workout, I'm doing lower body, upper body, day rest. Lower body, upper body, day rest. And total number of sets per muscle group per week doesn't need to be, again, I'm telling this for advanced lifters, not for beginners. Beginners need a higher volumes than advanced lifters because of lower voluntary activation, better chance to recover somehow, and but advanced lifters, they don't need more than 5, 6, 7 sets per muscle group in a week, divided in 3 sessions per muscle group in a week. This will be the best you can do for your muscle growth, especially if you are advanced lifter and you are natural lifter.